I'm Daze Thomas, Assistant Professor, Department of Artificial Intelligence and Data Science from SNS College of Engineering. Today's class will discuss about deadlock detection. In previous classes, we discussed what is a deadlock, how to handle deadlocks, deadlock avoidance, prevention. Here we'll see deadlock detection. This allows system to enter deadlock state, detection algorithm and recovery scheme. All these are discussed in today's class. Single instance of each resource type. If a resource type is only having a single instance, we maintain a wait for graph. It is having nodes which represents processes, and we have edges from PI. If a edges from PI to PJ, then it indicates that PI is waiting for PJ. Periodically invoke an algorithm that searches for a cycle in the graph. If there is a cycle, there exists a deadlock. An algorithm to detect a cycle in a graph requires an order of n square operations, where n is the number of vertices in the graph. Resource allocation graph and wait for graph. So you can see a resource allocation graph and the corresponding wait for graph here. Several instances of a resource type. You have available, allocation and request. Available as a vector of length m indicates the number of available resources of each type. An allocation is a matrix n into m matrix defined by the number of resources of each type currently allocated to each process. Request an n into m matrix indicates the current request of each process. If request ij is equal to k, then process pi is requesting k for more instances of resource type rj. Now we'll see detection algorithm. First step is where you have work and finish two vectors of length m and n. Work is equal to available for I is equal to 1 to etc up to n. If allocation not equal to 0, then finish of I equal to false. Otherwise, finish of I is equal to true. This is the first step. Second step, find an index I such that both finish of I equal to false, request must be less than or equal to work. Both conditions must be satisfied. If not, no such I exists, and you can go to step 4. Step 3 is work is equal to work plus allocation, finish of I equal to true, then again go to step 2 and repeat. If finish of I equal to false for some I less than or 1 less than or equal to I less than or equal to n, then the system is in deadlock state. Moreover, if finish of I equal to false, then the process is deadlocked. The algorithm requires an order of m into n square operations to detect whether the system is in deadlock state or not. Here you can see an example for deadlock detection algorithm. The deadlock algorithm usage. If detection algorithm is invoked arbitrarily, there may be many cycles in the resource graph, and so we would not be able to tell which of the many deadlocked processes caused the deadlock. Recovery from deadlock, that is process termination. Abort all deadlocked processes, abort one process at a time until the deadlock cycle is eliminated. So, in which order you choose to abort? First is priority of the process, second one is how long the process has computed, third one is resources the process has used. Resources process needs to complete and how many processes will need to be terminated, is process interactive or batch. All these conditions has to be satisfied or checked in order to choose the abort. Recovery from deadlock, resource preemption. So here selecting a victim will minimize the cost. Roll back, return to some safe state, restart process for that state. Then starvation means same process may always be picked as victim. Include number of rollback in the cost factor.